Year 2 A-level book, exercise 2F, question 4, about functions and transformation of functions and the modulus function as well. Okay, so we have to draw a sketch of this function g of x, which is defined as shown there. Okay, so as a basis, we're dealing with the parabola y equals x squared, but we've got to transform it. The -2 with the x causes it to move 2 units to the right, and the -9 causes it to move 9 units down. So the turning point, the minimum point, is, instead of being at the origin, is going to be at the point 2, -9. So I can start, I've just done an outline sketch of a parabola here. I know that this minimum point here is the point 2, -9. So I'm going to start by labeling that. Okay, 2, -9. Okay, and I'm going to put my axes in roughly in the right place to show that that transformation has occurred. So if we consider the x-axis to now be about here, so that point is now 9 units below, and the y-axis is going to be roughly here, okay, down here like this. Okay, and we need to label the crossing points and the intersections as asked in the question. So we just quickly label our axes. Okay, so on a sketch like this, the usual requirement is to show the axis intercepts and the minimum or turning point. So we've done that, and we just need to put some more information in. Well, because this is given as a completed square form, we can solve it quite quickly. So from there we can say that x minus 2, okay, equals plus or minus 3, okay, just by taking the 9 to the other side and rooting it. And then, of course, we just got to add 2 to both sides. So we get that x equals 3 plus 2, which is 5, or x equals 2 minus 3, which is -1. Okay, so we've got these 2 points here. This is the point here, -1, 0. That's the solution on the left here, and this one is 5, 0 here. Okay, so that's labeling those 2 points, and I'll just put a little mark there to show where those points are. And then we have to go to this point here, which is where it crosses the y-axis. Well, that would be when x is 0. Okay, so 0 minus 2 squared is 4. Okay, and 4 minus 9 is -5. So this point here has coordinates 0, -5. And that's it. So that's a sketch of y equals g of x. Okay, and we go on now to question B. Now in question B, we've got to write down the coordinates of the turning point where the curve is transformed as follows. So the first one is we're going to stretch it by a factor of 2 vertically, and we're going to move it right 4 units. Okay, so it's currently at 2, -9. All right, so it's going to be at 6. That's 4 places to the right, and it's also got to go down by well, it's currently 9 units away from the x-axis, so it's going to be 18 units away. So it's going to be at 6, -18. I'm just going to write it here. So it's going to be at the point 6, negative 18. Okay. And it just says write down the coordinates, so there's not much to do other than that. Now this is simply g of 2x. Now because the 2 is with the x and not in front of the function, it affects the x coordinate. In other words, it affects it horizontally, and it squashes it by a factor of 2. So what this will do is cause the x coordinate, which is currently 2, to become 1. So the minimum point moves to 1, negative 9. So it won't affect it vertically. Okay. And the modulus of g of x. Well, the modulus of g of x will simply cause everything that's below the x-axis to be reflected in the x-axis. So instead of being at 2 minus 9, it's going to be reflected right up here to the point 2, 9. Okay, 2, 9. And that is the answer to part B. Okay, now in part C, we've got to sketch the curve with equation y equals g of modulus of x. Now that's not the same as what we've just done here. That's effectively a reflection in the x-axis. This one here is a reflection in the y-axis of everything that's on the positive side. Okay, now basically what this means is that any negative value of x is treated as if it were its positive instead. So when x is minus 1, it would be treated as if it were 1, you see. So basically everything to the right of the y-axis simply gets reflected in the y-axis. So it looks something like this. I've already done this earlier, but I'll just bring it across from here. So it's hidden away over here to save time. If I select this and bring it across here, we can put the axes in the appropriate places and discuss what's going on. Okay. So that is the function basic shape, and as you can see, I've taken it to the point 0, negative 5, which is roughly here, and I'm just going to put the axes in now, and obviously the y-axis is going to go up through here like this. Okay, and the x-axis will come through roughly like this. Okay, and we already know that this point here is the point 2, negative 9. Okay, so the one on the other side is going to be negative 2, negative 9. And notice it says in the question, label clearly the turning points in plural, because it's expecting them to be 2. And by the way, you must be aware, this here is not a turning point. This is called a cusp, where the two lines point, literally switch direction. There's no smooth turning point there. But we do know that that point is 0, negative 5 from our previous question. Okay. And we do know that this is going to be 5, 0, as it was before. And because the other intercept is now a reflection in the y-axis, this is obviously negative 5, 0. Okay, and we just need to label the origin, and technically we should label the axes as well. And that is the function g of mod x. Okay, I'll just check that we've got all the information we need in there. I believe we have. Okay, and show the coordinates of all the turning points and all the x and y intercepts, which we've done. Okay, we should really put a bracket around that as well. Okay, so that is the end of that question. I hope that was helpful.